Okay. In 3.6 we have general definitions for triangles, and I'm sure you've seen lots of these, most of these before. The first vocab word is scalene triangle. A scalene triangle is a triangle in which no two sides are congruent. And I'd like you to write that all sides are different lengths. The second type of triangle is an isosceles triangle, and that's a triangle in which at least two sides are congruent. So the sides we're going to say are congruent in this diagram are AB and BC. And when you're talking about an isosceles triangle, the congruent sides we call the legs of the triangle. So over here next to leg, I'm going to write AB and BC. The leftover side is called the base. So we'll write AC over here. And it's just a coincidence that it happens to be sitting on its base. For example, I could draw an isosceles triangle this way, and this would still be the base of the isosceles triangle. Now we have base angles, which would be angles A and C. They happen to be congruent. I'll talk to you about that more in a moment. Angle A and angle C. And then the top angle would be the vertex angle, which in this diagram would be angle B. A lot of terminology associated with an isosceles triangle. Another type of triangle is an equilateral triangle. An equilateral triangle is a triangle in which three sides are congruent. Equiangular is a triangle in which three angles are congruent. I'm here to tell you today that an equilateral triangle is also equiangular. Like that. Just a few more terms. An acute triangle is a triangle where all angles are acute. An obtuse triangle is a triangle in which one angle is obtuse. And a right triangle is a triangle in which there is one right angle. For this diagram, I'm going to call angle B the right angle, leaving angles A and angle C to be the acute angles. Now the side opposite the right angle has a special name. We call it the hypotenuse. And so we're going to write AC next to hypotenuse. Now the leftover sides are also called legs. They're not necessarily congruent. So AB and BC are the legs of the right triangle. Alright, so that's the basic triangle terminology. Let's now look to the second handout I gave you, Notes 3.7. It looks like this. And I'd like you to just turn the page and put this in between page 38 and 39 in your packet. And these theorems you will be using in proofs, and we call them the angle side theorems, and they're theorems concerning isosceles triangles. Okay? So the first says, if two sides of a triangle are congruent, then the angles opposite the sides are congruent, meaning if you know two sides are congruent, then the base angles of the isosceles triangle are congruent. And you're allowed to write this in the body of your proof. You could say, if, draw a little triangle with two sides marked congruent, then draw a little triangle with two angles marked congruent. The converse is also true. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. We would call this one, or sorry, the first one, if sides and angles. We call the second one, if angles and sides. All right? And this is very key. This is within one triangle. Okay? Sometimes there'll be diagrams where there'll be two different triangles overlapping or something. I'll see kids trying to use this theorem. It's only within one triangle. So let's look at this triangle down here. If we know that AB and BC are congruent, what can we conclude? Go ahead, Alex.
Angle A is congruent to angle C.
Good. That would be if sides then angles. Good, and now we could talk about the converse of that. If you know that angle A and angle C are congruent, Matt, what could we conclude?
Then segment AB is congruent to segment BC.
Good. We call that one if angles then sides. The last thing we're going to talk about in regard to isosceles triangles is that we can prove a triangle to be isosceles. And I want you to cross off this bottom one. It's not false, but it's not how we're going to prove triangles to be isosceles. The way I want you to prove triangles to be isosceles is that if they have two congruent sides, then they're isosceles. Now, if you know they have two congruent base angles, you can go if angles then sides, and then say that the triangle is isosceles because it has two congruent sides. The last two statements are having to deal with that the larger angle within a triangle is always opposite the longer side, and the smallest angle is always opposite the smallest side. So let's draw a triangle for a second. I'm going to call this triangle ABC. Looking at the diagram, which angle appears to be the largest? Yeah, angle B appears to be the largest. Normally they would give you information because you're never supposed to assume relative size from a diagram. But if angle B is the largest angle, then what side has to be the longest side? Lucas?
BC.
Well, the larger angle is opposite the longer side. So opposite means across from.
AC.
AC. AC, longest side. And also the smaller the angle, the side opposite the smaller angle is going to be smaller. Okay? I'd like you to turn the page to page 40, and we're going to do a proof together. We're going to start with number 4.
Are we no longer proving two angles are two triangles are
Oh, we definitely are proving triangles congruent. In fact, we're going to do that in this proof. So we're just going to have some extra things to conclude. So we know XEB is congruent to YEC, and that XE and YE are congruent. So pretend you write the givens. I didn't mark the first given on my diagram. How could I use that first given? Chloe.
BE is congruent to CE.
Good. And why? I'll start you off. If a point
If a point is a midpoint, then it divides the segment into two congruent segments.
Perfect. If a point is a midpoint, then it divides a segment into two congruent segments. Nice. I see a pair of congruent triangles. Does anybody else?
Yeah.
Andrew, what triangles do you see congruent?
BEX and CEY.
Good. BEX congruent to triangle CEY. Byron, why do you think those triangles are congruent?
Side angle side.
You are correct. We have a side given, an angle given, and we proved the other side in step 2. All right, well, we're trying to prove that ABC is isosceles. Let me highlight for you triangle ABC. For ABC to be isosceles, that means that, if I draw it over here, that means that AB and AC would have to be congruent. Well, if that's true, then that means angle B and angle C would have to be congruent. We're kind of working backwards. Is there any way that we could get angle B and C congruent from the fact that we just proved the triangles? Christopher, what do you think?
CPCTC.
Exactly. We could CPCTC angle B congruent to angle C. So if those two angles are congruent, then according to what theorem that we learned today can we get the sides?
If angles and sides.
If angles then sides, that's how we say it, and this is how we write it. If congruent base angles, then congruent sides.
I have a question.
Yes.
Couldn't we have also done, couldn't we have also done bx congruent to, I mean, this is longer, bx to cy, cpt, cc, and then b, and then ba to cy, I mean, ba to ca, because if congruent angles are added to the same angles, then something congruent.
I think you mean congruent segs, but we don't have seg xa and ya to add, so we couldn't have done that.
Oh, yeah, you're right. Okay.
All right, and then our last step is to say that triangle ABC is isosceles. So I write triangle ABC as isos. And then looking back at our notes, we have this theorem. If at least two sides of a triangle are congruent, then the triangle is isosceles. If at least two sides of a triangle are congruent, then it is isos. Okay, we're going to do one more together. Looking at number 5, it gives us the perimeter. How can we find x? Go ahead, Griff.
We can do x plus 4 or plus
Mm-hmm.
2x plus 2
Uh-huh.
plus 16 equals 43.
Good. All right. Write it out. Solve for x. What is that? 3x. And 4, 2, and 16 is how much?
22.
Good.
Yeah.
Subtract 22 from each side. We get 3x's 21. We get x equal to 7. So we're done with the first part because all it said was to find x. Then for part B, it said which angle is the smallest. What do you think we have to do with that x? Eli? All the sides, because the smallest angle would be opposite the smallest side. All right, good. So 7 plus 4, it makes this side 11. 2 times 7 is 14 plus 2 makes this side 16. What's the smallest side?
Yeah.
AB. So Matt, what's the smallest angle?
G.
Angle G. You guys, by the way, what type of triangle is this? Isosceles. These sides are both 16. All right, nice job, you guys.